Hello and welcome to Electronic Solutions. In today's video, I am going to explain the PSW register of 8051 microcontroller. PSW register stands for the program status word. So now let us see this register in detail. The program status word PSW register is an 8-bit register in 8051 microcontroller. It is also referred to as a flag register. Now, although the PSW register is 8 bits wide, only 6 bits of it are used by the controller. The two unused bits are user-defined flags. The 4 flags which are called as a conditional flags are present in the PSW register. The conditional flag means they indicate some conditions that result after an instruction is executed. These 4 flags are carry flag, auxiliary carry flag, parity flag and overflow flag. Now we'll see the format of PSW register. Now in this format, if you can see, the bit PSW.7 represents carry flag, PSW.6 represents auxiliary carry flag, PSW.5 that is a bit which is available to the user for general purpose. PSW.2 is for overflow flag and PSW.1 is again a user defined bit and PSW.0 is used for parity flag. Now there are two more bits which are PSW.3 and PSW.4 which are designated as RS0 and RS1. These two bits are used to change the register bank. There are 4 register banks in the internal RAM memory of 8051 microcontroller. So to select a particular register bank, we are going to use these two bits. Now how to use these two bits? So for that we'll see this table. So if we put both 00 in the RS0 and for RS0 and RS1, the register bank 0 will be selected whose address is from 00H to 07H. When we put 01, then the register bank 1 will be selected whose address is from 08 to 0FH. If we give 10, then register bank 2 will be selected and the address of bank 2 is from 10H to 17H. And if we give 11, then the register bank 3 is selected whose address is from 18H to 1FH. So these two bits, that is RS0 and RS1, they are used for selecting a particular register bank. So this is what all about the PSW register. Now we will see when these carry flag, auxiliary carry flag, overflow flag and parity flag will set. So what are the different conditions for all these 4 flags, and then we will discuss one example. So the carry flag, which is a PSW.7 bit, is set whenever there is a carry out from D7 bit. This flag is affected after an 8-bit addition or subtraction. Also, we can set this bit to 1 or 0 directly by using the instruction set B carry and clear carry. That is also possible. The second flag, that is represented by PSW.6 bit, is auxiliary carry flag. So if there is a carry from D3 to D4 during add or sub operation, this bit is set. Otherwise, the bit is cleared. This flag is used by the instruction which performs the binary coded decimal arithmetic, that is a BCD arithmetic. Then we will see the overflow flag. The overflow flag is set whenever the result of a signed number operation is too large, causing the high order bit to overflow into the signed bit. So in short, we can say that whenever there is a carry from D6 to D7 bit, then in that case the overflow flag will be set, otherwise it will be cleared. And the last flag is a parity flag. So the parity flag reflects the number of ones in the accumulator register only. If the A register contains odd number of ones, the parity bit will be set to 1. and if accumulator has an even number of ones, then the parity bit will be set to 0. So these are the different conditions for which these 4 flags will either set or reset. Now we will discuss one example and I will show you the status of all these 4 flags, and also we will check the status of the PSW register with the help of this example. And afterwards I am going to show you the same result in Keil. So this is the example. Show the status of carry flag, auxiliary carry, overflow and parity after the execution of following instruction. So in this program, I am going to add BF to 1BH, and now we'll let us see what is the result and what is the status of the different flag bits in the PSW register. So my first number that I am going to add is a BF. So my first number is BF, and I am going to add this number with 1B. So first what I will do is I will write these numbers in the binary format. So first I will write down these bits. So D7, D6, D5, D4, D3, D2, D1 and D0. Now I will represent these numbers. So B means 1 0 1 1. F means 1 1 1 1. I'm going to add this with 1B. 1 means 0 0 0 1 and B means 1 0 1 1. Now let us see what is the result of this. 1 plus 1 will give me 0, carry is 1. 1 plus 1 will be 0, carry will be 1. 0 plus 1 will give me 1. 1 plus 1 will be 0, carry 1. 1 plus 1 will be 0, carry will be 1, but result is 0 plus 1 will be 1. 1 plus 1 will be 0, carry will be 1. 0 plus 1 will be 1. 1 plus 1 will be 0, carry 1 and 1. So this is what is the result. Now let us analyze the status of different flags. So let us first check the status of carry flag. So for carry flag, we have discussed that if there is a carry out from D7 bit, the carry flag will set. But in this example, there is no any carry out of D7 bit, so carry flag will be set to 0. The next flag is the auxiliary carry flag. So we have seen that the auxiliary carry flag will be set whenever there is a carry from D3 to D4 bit. So here if you can see, there is a carry from D3 to D4 bit, and therefore the auxiliary carry flag will be set to 1. Then there is next flag, which is an overflow flag. So for overflow flag, we have seen that if there is a carry from D6 to D7 bit, then it will be set. But here there is no carry from D6 to D7, so it will be set to 0. And the last is a parity flag. So here let us check the number of ones. So 1, 2, 3, 4 and 5. So there are 5 number of ones which are odd numbers, and therefore if the number of ones are odd, then in that case parity bit will be set to 1. So this is what is the condition, and according to that these flags will be given either 0 or 1 status. Now I will show you the status of the entire PSW register. So let us see the status. So what is the first bit in the PSW register? The first bit in the PSW register is a carry flag. The second is auxiliary carry. Third is the F0 bit. The next two bits are for register select, that is RS1 and RS0. Then there is a overflow flag, then one bit is not used, and last is a parity. So this is the format of our PSW register. Now we'll write all these values and let us see what is the result, so that we can check that result in Keil software. Okay. So here carry flag is 0, auxiliary carry is 1. This bit is not used, so I will put 0. RS0 and RS1, here I will select the bank 0. So for that both the bits are 0 0. overflow flag is 0. This bit is again not used, so 0 and P is 1. So what is the answer, or what is the number corresponding to this is 4 and 1. So my PSW register will show me 41H contents in Keil software. So now let us go to the Keil and let us check out the same result. So here I will open that project PSW. So see here the same program I have written, and here I will show you the output of the program. So once I will build 0 error 0 warning, and now I will go to the debug mode, start stop debug, and now I will check the result in this PSW register. Okay. So just check here. I will go for single stepping. So see, move a comma hash BF. So accumulator contains BF. Now after execution of this add instruction, we will get the PSW status. So here if you can see, after this instruction the PSW is showing 0x41, which is same as our previous result. So guys, if you like my video, then please subscribe to my channel and share the video with your friends. Thank you guys. Thank you so much.